programming tips, plus I will tell a little about slightly complex problem. This is more of a computer science problem, but not quite in physics. But still, it's a good idea to know something about this. This course is not really for programming; it's more numerical computing. But definitely, I would like to say if you give some tips. One important point is that you need to think of a problem, not think of a Python code. Okay, you're solving a problem like this Tower of Hanoi. You have to solve it. Computer cannot. Whatever until you solve it, you can't write a code. Right? So you need to first think of how to solve the problem. Then only you can code. In fact, first solve the problem, then write algorithm. So you have in your mind, this is how I will solve it. But you need to put it down on a piece of paper. Your sequence of steps. Okay, that's called algorithm. The algorithm is not quite the program, or neither. Whatever is in your brain, you have to put it on a piece of paper. That's algorithm in some sense. Steps. But algorithm must be understandable by a computer. Well, computer will understand a Python code, or C code, but it is step-by-step procedure. Okay? We can clearly state your procedure. That's algorithm. And then you write the code. So these are three steps. First, solve the problem, write algorithm, then the code. And it must be done for your homework problem as well. You should not simply jump into writing a code. And also, one important point is to think of extreme cases. So I'm going to show you some examples in today's class. Think of the limiting cases. Suppose, okay, I'm going to tell you a little bit later. Like your factorial code, ideally, we don't expect in this course, but if the number is too large, then it should give an error message. Otherwise, the code will keep going on forever, right, for a very long time. So that kind of things are limiting cases. So this code works for from n up to 1000, or something of that sort. But okay, you should think of limiting cases. But of course, I'm not expecting you to make a very. It covers all the limiting cases, but I will give some example a bit later. A clean design. It should be clean program. It should not be ugly code. Ugly codes may work, but it tends to break for limiting cases, or it may not work for all the cases. It's just it's like a house which is you're not made properly, so something happens, it may collapse. You still live in that house, but it's dangerous house. Think simple. Okay, that's for clean design. It's important to think simple. If it's too complicated, then the code is not. In fact, you can't understand your own code if it is written in a very complex manner. So there's a phrase called KISS. Keep it simple, stupid. Okay, so all the initial letters, if you put them together, is KISS. So it should be simple. Okay, it should not be too complicated. That's a phrase. By the way, these are all computer science. Big stalwarts have told this stuff. I'm just repeating them. Comment your code, but don't write too much comment, but write some comments. And good choice of variables. You should not write variable as I1, I2, I3, I4 like that, but you should choose names. For example, temperature should be written as temperature. You should not write as T or temp. So then the temp is usually for temporary variable. So just write it. It takes a bit longer, but it's very useful. So your program is readable this way. No go-tos. Of course, Python has no go-tos, but in other languages, go-tos are allowed, but never use go-tos. Okay, and it's not covered in this course. Structured programming, like object-oriented programming, is useful for large codes, but we'll skip that discussion. Now, I'm going to just do two problems. Search algorithm in two ways. Okay, so again, the idea is to solve a problem. Okay? So I'll ask you the puzzle. Okay, so that's the puzzle which often I ask in programming classes or courses. So I think of one among the four fruits. So banana, apple, orange, and guava. Okay. Now I think of the four fruits, and you can ask me a question, but I will answer only yes or no. Okay. So my answer is only yes or no, and you have to figure out what I thought about. Okay. So I will not play this game because this time is short, but you can play among yourselves, and you have to find the answer in minimum number of questions. Now, it turns out you can get the answer in basically four questions. Okay, you can ask whether it is a mango first. So I have to say yes or no. If it is yes, then done. If not, then I go to the next fruit. If is guava, no. So then I go on, and I can get in four. In fact, three. If the fruits are limited to four, then if once I finish three questions, then I get answer no, then naturally the answer is the fourth fruit. Okay, so so this is called you are searching one after the other. So this is illustrated here. The four students in a class, and I need to find the index in a register. So they are put in a list. Now I need to find what is the index of Rohit, the R index or the list index. So Rohit is 0, Sita is 1, and is 2, and Lakshmi is 3. So how will I find? I just see whether first person is. I think of somebody, So Rohit. So first list I search. Is it Rohit? First list. Yes, then I got the answer. If not, then I to go to the next. So the way I did fruits, I had to do in a list. So list of unknowns. I mean, well, basically, I don't know where is Rohit in the list, but I had to keep searching. Where is Rohit in the list? So this is called linear search. I keep searching I start from the beginning. Systematic computers are systematic, and they'll not randomly search, and we will not ask random questions. We'll just see whether this is my person who I'm looking for. If yes, return the index, else go to the next. Okay. And this unsorted array, here the names are, well, of course, there's you can think of first character and so on, but it will take longer in terms of characters and so on. I just think of four persons, four fruits. It will be easiest ways to go one after the other. If the number is not too large, unsorted array, you go like that. Okay, and the code is written like this. So def lin search, A is a list, and X is the element which I'm searching inside the list. Okay, now I'm putting this condition. If X does not belong to the list, okay, if this X is not in the list, then I should signal that. I should say that, okay, it is not in the list. So in this case, if I return index is -1, then that's a signal that the X is not in the list. Okay? Otherwise, I'll get index from 0 to n minus 1. So I put here for I in range, length A, for 4 is going to be 4. So range will create indices from 0 to 3 and say if AI equal to X. Okay, so is X AI? If yes, return I. Else, keep doing this loop.
Sir, I have some discrepancies. Sir, for loop के नीचे जो if लिखा हुआ है, तो if और else सर एक ही मतलब क्या बोलते हैं, if के बाद जो return I लिखा हुआ है, सर if के just नीचे जो indentation होगा वहीं पर से else start होना चाहिए ना?
No. It is for के साथ else है. Okay, so remember I had given this for else structure. So it is not if else. So that way it will just get out. No. I have to check the full list, and if it is not there, then only then I say return -1. Okay, this is after the for loop, not for this this if statement. Okay, you see from indentation, it is here. So this loop continues for all elements in the list, and if successful, it will give you I. If not, then it comes here and returns -1. So this is a guarantee that this X is not there in the list. Okay, so this is a nice feature of Python which I'm using here. Okay, so it's straightforward, and you please check it out. Okay, so this is a simple code, but you should do it yourself. Now the next question is, I can do the same puzzle with instead of fruits, I think of a number. So I can think of a number between 1 to 10, and I'll again answer yes and no, and you have to figure out what I'm thinking about, which number, in minimum number of questions. Okay. It turns out you don't need for 10 numbers, you don't need 9 questions. You can do it something like 4 questions. Okay, so and this is because the numbers are ordered. They are ordered, like 2 is less than 1. Sorry, 2 is greater than 1. 3 is greater than 2. So they're in ordered sequence. So it's sorted sequence. Okay, the ascending order sequence. So for sorted sequence, you can solve this problem in the following manner. So this is I put them in not 1 to 10, but the numbers are in the circles. Okay, 1, 3, 7, 8, 11, 15, 20, 25, 30. Okay? So there are 9 elements in this, and the numbers are 1 to 30. They are not 1 to 10. Okay? So the way to do is the following. Okay? I have to figure out what is the index of a given number if it exists in the list. Otherwise, say no, greater than -1. So I go to the middle of the list. So middle of the list is 11. Now check whether x equal to 11. The unknown is 11. Is it 11? If yes, I'm done. I give the index, which is going to be 4. Okay, 0. So this is the lowest index, 8 is the highest index, and 4 is the middle index. Okay, so this is a notation I follow. Now, so I know the answer right away. I just say the index is 4 and done. If not, then I see whether x is less than 10, less than 11. If yes, then I'm going to follow the left branch. Otherwise, I follow the right branch. So x is greater than 11 if it is not less than 11. So I search. Now I don't need to search all the elements. I search only half the elements. Okay. Now let's say x is less than 11. Okay, my number may be 8. Okay, so what do? So I come to the middle of these 4 elements. Okay. So middle index. So 4 cannot be divided equally. 4 cannot be divided equally, but there is no middle. 5 has a middle, but 4 doesn't have middle. So by the algorithm which I have in my code, middle will be 3. This element, index I equal to 2. No, I equal to 1. That index. Okay. Now then I search. Sorry, I ask the question: Is x equal to 3? If yes, I have the answer. If not, then again I ask: Is x less than 3 or x greater than 3? So again I divide into two tree branches, lower than 3 or higher than 3. Okay. Now I follow, well, x is greater than 3, so I come here. Now there are only 2 elements, so I come here and say, well, I divide 2 in, well, now there are 2 of them. So I ask, is x equal to 7? Yes. Then I know right now since there is 8. So no will take me to 8. Index is 3 for 8. So it's simple. You don't solve the big problem all together. You say keep dividing in half and half. So this is also called divide and conquer. So we are dividing the complex problem to each time half. Can you mute please, all of you? So we divide in half, and so then if you know it is the left half, then you solve the problem there. Well, it's also the trick used for in military. You don't attack the full army, but you attack uh, pieces. Okay, so this is how it is solved: divide and conquer. Okay? And you can figure out that the number of computations required is order log n. Okay? So you don't need n, but it's order log n, and this because it's sorted array. I can break into half. So you keep breaking in half, and that's why log n to the base 2. So this base 2. Okay, so this is a code. I've written a recursive code which is the simplest. So binary search from lower to upper. So the lowest index, and this is the highest index. X is the element to search, and A is the list. Okay. So mid equal to lower plus upper integer division 2. So we need the mid as an index. So this is the mid. Now I also want to take the limiting cases. If x is less than a lower, that means x is shorter than the lowest element. Whether I assume that a is in ascending order or increasing order. So if x is less than a lower, then it is -1. Or x is greater than a upper, that means x is bigger than the last element, then again -1. So for these two cases, the x does not belong to the list. And it's good to return this. So this is called limiting cases, and we should return -1. Well, the other cases, if lower equal to upper, that means A has only one element, lower equal to upper, and A mid not equal to x. So this mid will be same as lower or upper, right? Mid is just the average of the two, and which is it. And if A mid is not equal to x, then return -1. Then again, it is not in the list. Okay? So these two cases are for excluding saying that it is not in the list. Now come to else. The third case, neither this is true nor that is true. Then come here. Now I have a block. Okay, so there are more than one element, and the x is between the a lower and a upper. So if a mid equal to x, okay, then answer equal to mid. So this is index. So the mid is the answer. Else if x is less than a mid, then I should search in the lower half. I mean the left half, not lower half, left half. So answer equal to bin search, a lower, and I don't go up to upper, but I go up to mid -1. Okay, so mid -1, just one less than mid, and x is the element to search. Else x greater than a mid, then I search in the right part of the tree, right branch. So a mid +1, comma upper, comma x. Okay, and return answer. So well, return answer is after this thing is done. So don't put return here. You put return here because answer. I mean, if return here, I want one of the three cases. Well, if it is not the case, then you'll find answer here or here. Okay. So finally, I get the answer, and I will return that. So this is the called binary search or tree search, but it's a binary. It's called binary search. Either yes, no, that type, or left, right. You keep going. Okay. So that is basically an example of a slightly complex problem, and you have to think carefully how to solve the problem. And once you know the solution, you write down the algorithm, then write your code. Okay. If you rush, then your code will have some bugs, and you will encounter one problem or like not many problems of this sort in the exam, but you will give a slightly complex problem where you need to think about the solution. Now, there are packages in Python, which I said, and we need many of them for this course. So NumPy we already have encountered quite a bit. Math function, which is factorial, is part of math. CMath, matplotlib I will do in the next class. So this for plotting, and SciPy also we'll do it. This for eigenvalues, matrix, differential equations. It has many scientific packages. So SciPy is scientific Python. Okay. Okay, and you can import them. In my course and in my course notes, I give some description of what is the difference between these three. But you can just follow this approach often. Import NumPy as NP and NP dot the function name. That's easiest way to do it. Well, that's standard way to do it.